around.
Okay, if we'll all find a seat real quick, and I will introduce our speaker for today. I see a lot of people here with donkey cars. We're going to have, after the meeting, sort of a second meeting, if you want to think of it, where people with donkey cars can start communicating between themselves about all the things. So please be patient. Who needs a card from the group? If you just need where our website is or anything, can I don't see you guys in the back.
Yeah.
Name, please.
I'm Chris.
Chris, okay, I'm sorry, Chris. And
Josh.
Josh.
I've been to a few
Okay.
meetings in the past when I was still at UT.
Yeah, okay. I want to say you guys kind of look familiar, but anyway. So, all right, our speaker today is going to be Ray Casler. He's the club president. Ray has dabbled in OpenCV now for about 1.5 years, and it shows in his robots where he has used them in our competition 6-can and can-can soccer, where the task is fairly simple. Ray has a goal that he wants to eventually do it completely with vision, so that there's no odometry or navigational awareness of the robot, only simply that it can,
Maybe a
well, a little bit, but as minimal as he can make it and have it done by that. So along the way, he's learned a few things. He's also picked up a few techniques that are interesting, and he's going to share his experiences with us today, and think of it as part of the journey and not the ultimate OpenCV tutorial.
That's right.
And hopefully you'll find something that it will be beneficial, or at least stimulate some thought. So Ray, if you'll begin.
All right. So hopefully you'll think these routines are useful. They're kind of things that we use for our content. So one of them is blob detection. So to find or to locate something by its color. So there's other ways to do that. You can also figure out if it has the right size and the right color to discriminate, different size objects that may have the same color. And this is just kind of the outline or overview of what I'm going to cover. I call it pixel diddling. You're looking at individual pixels in a line or in a frame to try to get whatever information out of it that you're trying to get out of, and there's not really a set OpenCV statement to do that. So it's kind of like marching along a line, looking at every pixel in the line, or running down columns to try to find a white pixel in a black background, that kind of thing. The OpenCV is very sophisticated. It has a lot of different things in it. It's got built-in object trackers. I thought those were kind of neat. I'm not certain if we can use it for the donkey car or not, but I wanted to show it to you. Anyway, and then LiDAR. We've always, pretty much all the robots for, no, I guess Doug, you don't have LiDAR in yours.
Not yet, but
you
plans to put it on.
Right. Okay, so kind of like they say, many ways to skin the cat. I wanted to do it all optically, not with a mechanically rotated or scanned LiDAR sensor. So I'll show you what that looks like later. This last one, I kind of broke the law of presentations, and I made a claim that I can't really meet. So I can do some things with the Xbox Kinect, but it looks like the Raspberry Pi may not be powerful enough, or I don't have something set up right, because it maxes out, it goes up to like 90-some%, and it's losing frames, and in some cases it doesn't even start up. So not quite there, but I thought I was a few days ago when I made that one, so, and we put it in the agenda. Anyway, but I can show you some things with that. And again, using the Xbox Kinect sensor that was doing things, you know, with computer vision, basically. It was using a depth map to try to locate objects or find out where objects were. And actually I think, oops, did I go one ahead? I think I went one ahead. I went multiple ahead.
The whole presentation.
Ah. Oh, that's right, yeah. Okay, so blob detection. One of the things that OpenCV is really good for, and I'm just going to switch and show you kind of the effect and then go over the code that you use to generate it. Okay, so the kind of the goal with this is in 6CAN you've got, or can soccer, you've got 6 of these orange cans out there, and they're kind of placed randomly in the. Oh, there we go. Kind of placed randomly in a soccer field. So typically you want to find the closest one first, so you can grab it, bring it to the goal and drop it off, and then you want to find the next closest one, and so on. In this setup, the Raspberry Pi is doing all the OpenCV stuff. It actually has a little board on top. It's made by Polulu. It's got one of the Arduino processors on it, a 32U4. It's got a switch mode power supply that provides power to the Pi and the board on top. It's got motor drivers, level translators for I2C, and other interfaces between the Raspberry Pi and the other board, because the board on top runs on 5 volts. The Raspberry Pi typically 3.3. So it's got a lot of stuff. It's very useful. I use it for PID loop control. The board on top, that is. So it's actually reading outputs from the encoders and trying to set a specific speed or turn at a certain rate, that kind of stuff. So basically the only thing that I need out of the Raspberry Pi is an X value. So in the field of view, Y doesn't matter so much. The can be, it can be further back. And there's kind of another strange thing that's going on here. It will highlight the closest can, and it'll find the center of that blob. So you can turn this sideways. Now it's looking at that one.
So that's what the little white target is?
Yeah, that's the centroid of the blob. It's kind of like the center X, center Y of whatever those pixels are.
And that's an inherent CV function?
That's something that you can get out of it. And that's what I send to the board on the top, and that's this stream of CXs is actually the center X value of the closest can. So, depending on, okay, right now it's highlighting this guy because he's closer. If I move this one, you should switch to it because now it's closer.
Is it deciding closer just by size?
Yeah, the number, basically that, kind of like the green line is actually a contour around the blob. And so, yeah, the more pixel it has, the bigger it is. It's kind of weird, I don't know why they did it, but I guess whoever wrote the little thing for contours, you can actually list them the smallest first, so that would be the can that was the furthest away, or the biggest first. It's basically a switch that you put in the statement. So these things on top here, they're just a bunch of sliders. This one is for RGB, or red, green, blue. So I have 3 for red, green, and blue low, 3 for red, green, and blue high. And I'm picking or selecting the colors in the frame with those. So whatever's between the low and the high, that's the color that it's going for.
So you basically kind of put a low and a high RGB to get a color space that's orange-ish.
Orange-ish, yeah. And it's got a little bit of red and a little bit of green in it. And this image looks a little strange because one of the things that that you can do, I forget how many different modes there are, maybe 10 different modes that you can put the Raspberry Pi camera in. One of them is cartoon mode. And this is in cartoon mode, so it limits the number of colors. It's kind of like a cartoon or a comic book. You don't have an infinite number of colors in the print. It's done with so many colors. So that actually makes it easier to be able to find that color or that range of colors, because there's actually, it looks like there's 2 colors in there that, are made of the can. But if I took it off, there'd be many, many more colors, kind of a range.
So Ray, are you saying so we're talking about the middle one now that has the cartoon mode?
Yeah.
And are you saying the cartoon mode function is done by the Raspberry Pi camera?
Yeah, it's a mode that you can set the camera.
Huh, so because, and those features should be available within OpenCV itself. But it's interesting that you can do it within the camera itself too.
Yeah, you can, basically on the front of the code for it, that's where you set it. You can also set the number of pixels. These are 320 by 240. The bigger the frame, the longer it takes, and you're just going over that many more pixels. So 320 by 240 is good. The line following stuff, I think I went down to 160 by 128, so it's even, it's like a quarter of this image. Sure.
Is that slider dialog something that you wrote to provide input to the OpenCV function?
Yeah, yeah, and it's just, you slide them over, basically with a mouse.
Right, but it's not a function provided by OpenCV.
The trackers are.
Right, I got it.
But
Yeah.
the slider controls, is that a,
You're providing input to the
Yeah,
OpenCV function.
right, via these,
So how did you create the dialogue, I guess? Are you using some of their functions to build those controls, or are you manually drawing that stuff?
no, it's a built-in function, and I can get up the code here and show you.
part of the OpenCV library?
Yeah,
Okay.
The OpenCV library includes sliders where you can specify the minimum and maximum range that the slider is allowed to go through, as well as what kind of slider you want.
Oh, okay.
yeah. So, and a lot of these, almost everything that I've done comes from, I think his name is Adrian Rosebeck. He's got a website called Pi Image Search. And he gives examples, he sells books. For me, it was the easiest way to learn it, because I knew nothing about, OpenCV when I started. Kind of one of the goals is to get this mask screen where you have basically a black background and white, white images or white blobs on that, because the contours aren't actually done on that image, they're done on the mask image. And so it's looking for a continuous blob of things, and it does, it's picking out orange there somewhere in the scene. I don't know what it is, something.
Probably might be the
orange
cord.
cord over there.
Yeah.
And I don't know, whatever else is orange here. Oh, that's kind of an effect, this circle here. On the Raspberry camera, I have a thing called a filter switch, because when I use the laser, I want to change the wavelengths that the camera sees. And those two filters allow me to do that. So, those are in just about every security camera. If it has, a ring of infrared LEDs on it, it's actually switching back and forth between the two modes. It senses the amount of light, and when the light gets too low, it flips the filter switch. And basically, there's an IR cut. Well, it's UV and IR cut filter that gets switched out of the way, and it's just a filter that lets in, I think it lets in visible light, infrared light, and I think it has an anti-reflective coating on it, and that's it.
So that's what's causing the artifacts around the edge, is what you're saying?
Yeah, this is, I wish I had an optics lab. I don't,
You could mask that out too if you wanted to. You could just mask that area completely out.
Yeah, but basically what it is the filter mask is interfering with the field of view of the Pixie camera, because it's on front of it, and so it's kind of like a tube, and it's seeing the edge of the tube here, or obstructing. What's that?
If it doesn't cause a problem, you just leave it.
Yeah, but that was, what I could get from, Banggood and eBay. I did find another one. It doesn't use the Pixie camera as the base. It uses the, there's like OV and then 4 numbers after it. And it uses the 12 millimeter threaded lens barrel, and it actually had the filter switcher behind it. And I think I'm going to get one of those, because that, it does kind of clip off the image, and you can kind of, you'll definitely see it here, so that the thing isn't quite centered and it's not quite big enough for the field of view of that camera.
And just to be clear, you mentioned Pixie Cam, but you also mentioned Raspberry Pi Cam. Which one is this?
This one is actually the Raspberry Pi camera. You can also use a Pixie Cam to do this, and there's other cameras. The OpenCV M7, there's an H7 coming out in a while, and you can do similar things with those as well. The H7, you can stick, they call it a global shutter. You can get up to like 240 frames per second out of it. It's just a black and white sensor. It also works with both really long wave, heat sensors from FLIR. You can put those on it, or you can put on the OV series of cameras that are kind of what would be like on a Pixie Cam or some of those other cameras. So anyway, so look at what the code is doing. I'm just gonna open it up.
You got
I got Donald Trump's keyboard here, so it's kind of small. Okay, so here's the code that's actually creating these images and really performing all the functions. Start off, and this is in Python. You basically have to import, whatever packages you're using. So there's quite a few. All the OpenCV stuff is in CV2. there's a bunch of initialization stuff that you can do for the camera. One of the image effects is cartoon, so this is in cartoon mode. The other is that you can set the frame rate, you can set the size, and you're actually taking the image and putting it into a NUPI array. And the array is actually, it's an XY array, 320 by 240, and it contains 3 bytes, one for each of the red, green, and blue. I don't know what you call it, I guess intensity, or strength, so it's a range 0 to 255.
Is that what comes native from the camera, or does it just basically get translated to populate that format?
No, the camera, I think that will go up to like 1920 by...
No, I mean the
4,000
format, the
something.
RGB.
Oh, yeah, it's kind of weird, but it actually comes, instead of an RGB format, it comes in a BGR format. And you might have heard of HSV, or, RGB is, I don't know, maybe one of the more common. But there are literally like 100 different ways to specify how that stuff comes across. There's,
I know there's hue
Yeah.
and a few other those things, right? They all mean the same thing, but they're all vastly different numbers, and I can never keep them straight myself.
right, you can have different numbers of bits. It could be luminance, chrominance, and I don't even know what the third one is, but there are literally like 100 of them that OpenCV supports. So it's
Well, what's coming from the camera?
what's coming from the camera is it's a BGR format, and there's a thing to actually change it to RGB.
But otherwise, it's just confusing a couple of the color channels if you
Yeah.
don't have it mapped correctly.
Switching the two, yeah, and if you didn't process them like they were in that order, you'd get totally screwed colors, because it would be, messing with the wrong color channels. Anyway, one of the things that you have to specify is an I2C address. So that's what that address 0x04 is. It's just an address that you set up on the A-Star controller that's on top of the Raspberry Pi and the Raspberry Pi, so they can communicate. One of the things that happens with a lot of the CV routines is you have a thing called a kernel, and it's the same thing with I think convolutional neural networks. The kernel is it's a matrix, and it's populated with certain values, and when you pass that kernel over the image, it does certain things to it. So like in Sobel transforms, one of the things is it looks for, or that it highlights, is a transition from black to white. And you can do Sobel in the Y direction, and I use it later in one of the other programs. You can do it in the X direction. Or you can use edge detection where it does it in both directions. So it finds that transition, and it's not black to white and white to black, it's just black to white. That's what it's looking for. So those, and I don't know the mathematics of how that works, but that's how a lot of these things are done. You're actually passing a smaller little block over the pixels of the image, and you're multiplying those values with the values that are in this little kernel, and it does things to the image. So and there's explanations for it. I think, Doug, you had a book that, or a reference that had a pretty good explanation for what actually.
Yeah, well, you're just talking, that's a filter. You're just putting a filter on it.
More or less, yeah.
Yeah.
Yeah, but that's what a lot of the OpenCV things do. Let's see. Lost my mouse again. There it is. Okay, so this is creating the track bars. That's these things up here, the track bars or sliders. And it's basically, you know, it's passing the value of what that track bar is back to these things down here, these the variables basically. So B low, G low, red low, you know, and blue, green, and red high. Now this says it was an HSV image. This one is not. Didn't update the comment in this code. But you can use it in HSV images.
Okay, so the create track bar is what's creating the sliders.
Yeah.
And they can range from 0 to 55, and then they have the title in the first field of the array. And
Right.
then what's the nothing? I'm just curious.
Oh, the nothing is you know, defines a function, and all it does is pass the value of what you've set on the slider to those variables.
So it's a callback.
Okay.
Yeah, more or less. Yeah.
Okay.
So one of the other things that, maybe I should switch to the other keyboard, this one. Oh, there it is. So in this case, I set an upper, you know, I was looking for the color blue, so I used lower blue, upper blue. And it's basically those images combined. So here, basically it creates an image called mask, and it looks for all the things in that image that are in range between lower blue and upper blue, which is described as, you know, the values from the 6 sliders. One of the other things that you can do with OpenCV, it's called image morphology. If you have a lot of noise in the image, one of the things that you can do, it's called either erode or close, morph close, and it will actually reduce the kind of the lone pixels that aren't kind of in a blob or in a bunch with others. It will also erode, the ones that are around the outside edge, so it'll make the blobs smaller. And when it's just one pixel that's flickering on and off, you can basically eliminate it. Morph open and dilate does the reverse. It will actually increase the number of pixels around the blob, so it'll actually fill these in. And so they're just image effects that you can do if especially in lower light conditions. You can have kind of a noisy image. It'll be kind of on the edge of, there'll be a lot of things dancing in the image, and you can use those to get rid of those. A lot of this stuff is commented out. Anything with a, with a hashtag in front of it is commented out. Let's see, yeah. So, and you can do kind of like logical functions with it there that use actually a bitwise and, but none of that stuff is being used. So, kind of the next area that it does is find the contours and the threshold of images. So it wants to basically try to find the blobs in the image and draw a line around them. And from that, once it does that, you can sort them. You can say how many of them you want to highlight. Like in this case, this one here, I'm just highlighting the biggest one. So that's the reverse equals true. They're actually sorted lowest or smallest to largest, and that reverses it to, largest to smallest.
So is that the green lines?
Yeah,
basically?
That's what the green line is. The okay, and this is where it finds the kind of the moments, the centroid or the center value in the x direction and in the y direction of that blob. And and it doesn't matter if the can's laying on its side, it'll track it if I can do that. Okay.
put them together.
Yeah, it'll form one huge blob. It won't separate them. Okay. One out, okay. Yeah, so it'll track, you know, independent of orientation where it thinks the center of that pixel is. And with a selection, it'll pick the one that's the closest one, so it should be highlighting this one because it's closer. And if you know.
Well, do this, Ray. Pull one forward.
Okay.
Pull one forward. Now take it out of the frame.
Okay, yeah, it'll switch back to the other one because it was further back. So you can, for our purposes, that's probably what you'd be doing because you typically want to go after the closest scan first and bring it back to the goal. And the X value is what I need to steer. So it's differential steering. If in this case, if it's sees it at 360, which is the center, because it's 320 pixels across. Center, okay. So that's about 160 now, 159, 160. That's the center of the image. Basically, I'm kind of on track to, I don't need to steer left or steer right. I think it should go, that side should be very low, so it should go, it goes from 0 on that side to, closer to 320 on this side. Actually 0 to 319, but, and that's what you can use for, to steer towards an object. Yeah, so down here, the draw contours, this is the color that you can select to draw it. It's 0 for red, 255 for green, and 0 for blue. And then the little circle is, it's just showing you where it thinks the center of that blob is. And you can put text on it. I didn't want to do that, but that's another thing that you can do. So to tell the little board on top, I've got to send that through the I2C bus. And typically, you have to have like a starting flag or a number that you can recognize in the stream in case you get out of sync. Because this one, let's see, CX. Okay, yeah, 320. If it's over 255, it takes 9 bits. So what you can do, these two are commented out. You can actually shift it a bit, and then once you get it on the other side, you can shift it back. You lose 1 pixel in resolution. It's always even. Because you've shifted it off, you don't know whether it was a 0 or 1, so when it comes back, it's always a 0. And then you don't have to frame it because you're only sending a byte each time. So, that was a way to kind of implement this quickly, and because if you're framing it or not framing it, both sides have to agree. Otherwise, you're not going to communicate things correctly. And
So Ray, the pi is the master, right?
Yeah.
Okay.
Yeah. So, let's see, what else is in there? The image shows, these are, they just basically display these images on the screen, and when you're running it, these take time to display on a screen. You're pretty much running it headless. You don't need to see any of this stuff. It doesn't, the only thing that it cared was to, send an X value so you can actually steer with it. So it's, that's kind of it for blob tracking. And, okay, the next thing that I wanted to show was pixel diddling. kind of experiencing one of the things that the little cameras experience, glare, which is hard to deal with.
Huh.
Come on. There we go. Okay, so one of the contests that we had, it's called the Challenge Line Following course, and it's got a lot more things in it that will trip you up. In fact, I think every block is meant to trip your simple algorithms up. Yeah, I was gonna say too bad we don't. Do you?
I'll pull a
Okay.
sample on my computer and hold it up.
Okay.
Keep talking. I'll pull
Okay,
it and show it.
great, thanks. Anyway, one of the things that I thought I could do to solve this thing was to look at a single line of pixels, because you're always looking at either a black line on a white line on a black background, or a black line on a white background. And the line can curve around, it can have breaks in it can have segments in it. You've got several transitions between the white background and the black background. I'm trying to think you have stains. You have popsicle sticks to run over. It's, like I said, it's a minefield of things that, will trip you up. You just can't use it like a simple approach or simple algorithm for it. So one of the things that I did is I wanted to take a look at a single liner. That was the first approach, and that's the approach I'm showing here. And then try to figure out what was in that line of pixels. Was I looking at a white background with a skinny little black line in the center of it, or what was I looking at? Let's see. Oh, okay. Is there a cord over there? Oh, okay.
Do you have one,
Yeah.
Carl? Do you have a cord?
Somewhere.
Yeah, there was only.
I've got one in my backpack.
Oh, okay, great.
We're good. I'll just walk in front of you.
Oh, that's fine.
What if you just cast to it?
Next time,
Anyway.
wave, Carl.
So the kind of what I saw in the line, or how I analyzed the line, it would do, tell me certain actions or tell me basically where I was in the course. And if it was just a solid white or a solid black line, I don't know if there's solid black in the course. I think it's solid white. There's a gap. So you have basically, you're looking at solid white. There's no line there. And in that instance, I would use what I call my last X. So whatever X value for steering that I had, I would use, because I had basically no information in that area. It's the white cow in the snowstorm. There's nothing to see, or nothing to guide you anywhere. The course has several right angle bends in it, and so that I called
It's connected.
two regions.
It's a matter of selecting.
Yeah, it's hard to figure out which one it's on. This thing has way too many input. 3 was kind of the ideal situation where you had either, white line on a black background, black line on a white background. And that's what most of the course is. So if I had 4, that says I'm transitioning from a white area to a black area, or a black area to a white area. And I would just, again, kind of coast through it or use the last X value. And 5 is where there was actually, a fork. And in the course, if you look at it, in each of the areas where it forks, or you get that, 5 transitions in it, you always take the right side of the fork. So, and that happens over here at the end. You want to take this right path, when you're coming around this, you want to turn to the right. Let's see, and I think that's it. And I think, let's see, yeah, and these right angle transitions can be to the left or to the right. And, you know, I had to figure it out. So there's the stains. The stains aren't quite as dark as, you know, the dark stains anyway, aren't as dark as the black line or as white as the white line. So you have to try to navigate through that. And those are kind of tricky. Those will, you know, will easily throw it off. There's segments, there's different line widths. Like I said, it's the minefield of courses, so.
Evil.
Yep.
It's pure evil.
Let's see if this is gonna do this. It's picking up 5. Yeah. Yeah. 1, 2, 3. Okay, now this is one of the effects. Usually I pull that filter off because it's seeing the tunnel. So I don't know if I can demonstrate this. I might be able to. This little teeny tick here in the center, pretty hard to see because this is only a 160 by 128 image, but that's what it thinks it should track. And in 5, it should always track the second one to the right. So if I can move that around, the dot should stay with it because there's one here. It counts it as 1, 2, 3, 4, 5 regions. And that, even though it's reversed in color, looks like what that one region, where there's a fork, where I have to turn. Okay. I wonder if I can lower that, get rid of that effect. Oh, no, I probably can't. Anyway, so that's one of the things that it's supposed to do. And again, it just needs an X value to be able to steer. And it doesn't, it's always looking at the pixels in the very center line, well, okay, it's close to the center, I think it's line 60. Out of, let's see, 60. Yeah, it was 60, and it's actually 128 lines, so it's not quite in the center, but it's pretty close to the center. So, and you want it to be able to track fast enough so that if this line curves around one side or the other, that little dot keeps up with it. And it pretty much does. You can see the values of X changing up there. And it's the max T index is the number of transitions basically from black to white or white to black that you see in the line. So in OpenCV, the setup is the same. The camera image is smaller. It's 160 by, well, it actually says 120, but it actually puts it in 128. And I didn't change that. And I think it tells you that at the beginning of the program, or when it runs, it says, for some reason, I don't know why it chose 128 over 120, but that's the option that you have for that size image. So same sort of thing. You're actually grabbing, basically a frame and sticking it in a NUPI array, and then you're processing it. So here, some of the things that's done that are different. You're where is it? Converting it to gray, so it goes from it's blue, green, red to gray. It blurs it, and then it thresholds it. So it's and you can always put out these other images to see what they look like. Kind of the raw image, and or the image from each step to see if what you think should be done is actually being done to it. But then once you get that set, you don't really need to see that image anymore. It's just for your verification, more or less. This sounds kind of weird, but when things are thresholded, if you blur them a little bit, they actually threshold better. So you would think that that wouldn't matter, but it seems to with OpenCV. The Gaussian blur, there are several different blurs that you can do. Gaussian is supposed to be one of the better ones, but it also takes more time. So it's, again, it's a trade-off of you kind of do what you have to do, you know, for a certain frames per second or a certain update speed. And, you know, for, even though it says, I think 32 frames per second, it's not, it's much slower than that, because you can kind of see, like when the transitions run up for the X values, it's kind of hard. That one's actually pretty fast, but the slower ones, you know, they may tick by at one per second. You know, they can be extremely slow, and that's not very good. That's too much delay. And in the loops, like the pit loop is updated 20 times a second. So if I can have updates faster than that, you know, I'm not lagging behind. It's my motion is going to be much smoother because I'm getting updated as often or more often than I'm actually updating the control loop. And if it's slower than that, it'll just use whatever the past one was. So you get kind of like stepwise motion, or because it, you know, you're not updating it as fast. So the pixel diddling part is down here. So what I'm actually doing here is I'm walking through a line 60, with the column index, and so I've got basically 0 to 159, you know, the pixels in that line, and I'm looking to see if they're a value of 127 or greater. And so the thresholding, once that's done, it's a pure white or pure black pixel. So these are either valued at 0 or 255 for the white. So 127 is kind of in the middle, and it was just an easy thing to say, okay, is this white or is it black? So what I do is I count the number of pixels in a region, and you know, I also denote whether they're black or white, and what the column index was when that region ended. So here I'm going to have 5 you know, individual regions, and each of this the trans array is going to have those 3 elements in it. So here it's 1 for white. This one is trying to count all the white pixels. So if it's white, it's 1. It puts the count in the line for how many pixels it was, and then the ending CL. And here it's just doing it for the black lines. So again, it's going across line 60, all the pixels in it, determining which are white, which are black, and filling up this, you know, the trans array. So what I do after that, yeah, so I count the number of transitions. So, you know, it could be, and that's actually what I'm printing out there, the max T index, it's 5, because it had, in this case, 5 regions in that line. Okay, so then what I do is I try to figure out what to do with the information in this small array. So if my max T index is 1, that's 100% white space, so that's in the area here in the gap where I'm cruising along and I don't have anything except white. So that one line was to take care of that situation. If I have 2 regions, which is down here, I actually have to figure out, it could be an angle in a white region, or it could be an angle in a black region. And I want to because the field of view of the camera is typically larger than the square, I've got to figure out, okay, is it a black background or a white background, and how to turn. And so and part of that's actually handled by the code on the other processor. So I can handle gaps and I can handle right angles. If I have 3 regions, that's the easiest because it's well defined. I've got white background and line in it, so I'm seeing the 3 regions, and that's kind of ideal. That's the easiest way to steer. That's pretty much not this, but all these areas here where you don't have a right angle, and that's kind of the easiest case is when you have 3. 4 is when you cross from a white region into a black region or vice versa, and you typically never come up to this region perpendicular to it. So, you're tracking, you're in like a region of 3 here, white, black, white, and if it's at just a slight angle, you can get 4 regions, or if it's done just right, a right angle, you can get 5 regions. So in 4, I just go through it. I use the last X until I'm back to, in this case, 3. So, and that, that happens in all of these. If you don't line up perfectly, you're going to get, 4 regions in it. So, does that make sense?
Yeah.
And then 5 regions is where you have a fork. Like here, I'm going to have 5 regions, 1, 2, 3, 4, 5. But I don't want to take the left fork. I want to take the right fork. And same thing here, 1, 2, 3, 4, 5. I want to take that fork because that gets me to the finish. This turns me around and doesn't get me any points. Anyway, and then so the max T index, the number of regions, and where to turn is passed to the board on top, and it decides, because this one, it actually, and I haven't implemented that yet, but I think that's why it's not working right. I actually have to see several 5 regions in a row before I should make that turn, because if this is transitioned or there's a little glare there or something, I can see 1 5, transition number 5, and it'll screw me up. I've got to see actually several in a row before I actually know, okay, yeah, this isn't just, transitioning into one of these areas from white to dark or dark to white. But I haven't implemented that yet, so it's kind of got into the, looking at the next shiny thing, which in this case was the donkey car. So, anyway, so that's an example of what you can do. Anytime you do, you're looking at individual pixels in a line and processing them this way, it's going to be slower. It sounds kind of weird, but a lot of the built-in functions actually operate faster. Let's see, what was it? One of them. Item set, which is it's a way to set pixels in the image. Is actually faster. It's actually faster to use this built-in function than it is to use, the matrix notation for the image. So, anyway, the end there, it just sets, these are individual pixels that I'm turning on to a mid value, 127, because I never know if I'm in a white line or a black line, so that's the gray value in the middle, so it'll show up in a white line or a black line. And it's just a kind of a visual indicator, because if this tick, gets stuck over here, or it's not moving around, like it would be for 4 regions, then I know that, it's behaving the way I expect it to. And this is kind of what I call the program slag underneath it. It's all the other things that I've tried that are commented out now. One of them is doing a, can you transform on it, and that finds edges in both directions. Just kind of experimented with different ways of doing it. I think this one was also used. Let's see if I can go towards the edge, if this was the one. Nope, that's not the one. Anyway, it's just kind of stuff that I probably should have gotten rid of out of the program, but kind of haven't. And it's really easy to experiment with these things, and if something doesn't look like it's really doing what you want, or changing the image that much in the way that you want it, then just get rid of it, because the more stuff you do, the more time it takes, and you want to kind of maintain a certain update rate, which in my case is at least 20 times a second. Anyway, okay, so that covers the first two. That's blob detection and pixel diddling. And next one was built-in trackers. I'm not certain whether this can be used on the Donkey car or not, but it was kind of a neat thing that, at least I thought it was kind of neat that it had in it. And there's actually 7 that they tested. There's an 8th one, but it's much more difficult to use. They have all kinds of different names. I think boosting is the oldest one. It's not used that much anymore. So the ones with the names CSRT, KCF, which I usually think of as Kentucky Fried Chicken, but you have to be dyslexic, I guess. And Moss really performed the best. And to demonstrate what they are, back. Raspberry Pi. Okay, so this is it's just an MP4 video clip. And it's, in Boston. And, got it right in Snowflake. Ah. That's just crazy. That's crazy cool. Okay, I kind of time it with the windshield wiper to stop it. And what I can do is select the back of this car, and it will track it in the image. So I was thinking we might be able to use this to steer our cars with if we could track the line. And I tried it with an external camera, and it seems to track the line. The frame rate's not super fast, but I think, that's because it's a fairly complicated image. So, kind of a neat thing built in.
Which one is that?
Huh?
Which one is that?
This one is KCF, and it.
So this is an OpenCV function then?
Yeah, there are, they just call them object trackers. So you can select in a stream what you want to see, and it'll track it for you.
But I wonder if tracking an edge or a line or something might be difficult for that function.
I
Because-
tried it.
Oh,
and
you did?
It worked at home.
Okay. So much oil.
There's your answer.
Here's what it's
I'll quickly
So it works for what I know.
So I was thinking the
Yeah,
same thing.
what CPU?
Yeah.
The line goes all the way through. It's-
Yeah.
But it'll track it. There's another one, this doesn't seem to change that much, it's tracking the back of the car. There's one that's a horse race, and it actually tracks, so you select the horse, and it actually goes around the whole track, and even though it's changing perspective from the camera, it still tracks it. Another one is a bunch of sprinters, like doing, I don't know, it might be a quarter mile or something, and same sort of thing, it's not the left view of the runner running by all the time, it's, him going around the whole course, and it seems to track it, so.
Does it switch people?
No, it stays on the person that, or whatever you select, on the runner that you select, or the horse, it stays on it.
So if we were to try swarming and have a platoon go around this course, you could follow the leader, right? As long as,
It could, yeah.
as long as
yeah.
one robot
That's
stays on
right.
the course, then you could,
It's kind of like if you're not lead dog, the view never changes, right?
well, that's,
Isn't that the definition of lemmings?
that's right. That's, especially in our case where nobody really makes it around so well.
It'd be interesting to see what the donkey car would do on this track.
Yeah.
If, you trained it 20 laps, how well it would do.
Yeah, yeah,
That's, and it would take a while at 20 laps too, but yeah.
yeah.
How big is that?
Each one of those
some of
red
the turns
squares is
are
a foot.
little tight.
Okay.
So when mine made it around with 2 resets for 3 minutes,
Yeah.
it took 8 minutes. Of course, mine's kind of slow, but.
Yeah.
And one of the things that I
I'm
actually
slow.
had it output where that was in the frame, so it's an average of the left side and right side, the X value of the box. So, and then, the clip ends and it just stops. But yeah, the one, I don't know, I thought it was pretty impressive with, if I can find the one with the runner in it.
So Ray, if we do the donkey car, we could have one donkey car that's going around the thing with neural net, and then yours could just follow it.
Yeah, yeah.
And
Yeah,
just-
but that means it would never win.
Yeah, but it could come in second.
So you're the first loser. It's okay.
Well, 5 seconds before the finish line, you push the other one out of the way and
Yeah, just
takes the lead.
close to the
Yeah,
end.
but maybe if you know where the finish line is, you could do the zip around NASCAR thing, right? Maybe that's not a bad plan.
Yeah, you're just drafting.
Yeah, I'm just drafting.
Drafting all the way
racing,
around
maybe.
and then.
Saving the energy.
You go fast enough that we're drafting.
You gotta put the wing on mine, it'll go faster after I put the wing on mine. Yeah, that's what I'm gonna do.
Hey, if somebody has a lot to say, kind of wave at me and I'll make sure I pan over to you. Like if you got a long question, I'll actually move the camera over to you, but otherwise, I'm just gonna take it as just noise.
Banter.
Yeah.
How much wood could a woodchuck chuck?
You turn on the AC. Yeah.
Not that much.
And the air conditioning.
Okay, so this
Well, I'm
is
trying
the
to
one
put
that
an intelligent AC system at home.
Send bolt on.
This is,
Oh, okay, hang on, let me zoom in on that.
That's interesting.
yeah, it's just a touch screen. I have this mechanical, I'm buying a house in the year, so I'm not gonna fix this apartment up.
These in the late
So it has just a
80s, early
mechanical
90s.
sofa though, which you just click on and off and
Except it was from
based on the outside
tanks.
temperature.
So you blew them up.
I'm not making the house 65, it's 105 outside. So it's money.
And don't run the AC when it's
Okay, this is
40
having a
minutes.
little bit harder time. I think
Yeah.
policy works, yeah.
Interesting, because he
And I finally got
changed.
the heat pump is
I don't know
fine.
if I
Angle.
selected him that well, though.
Well, you know what? He changed his appearance quite a bit. He went from front view to
But
side.
it will track it, though.
Oh, okay.
I think,
76,000 off.
Are we tracking them at the moment?
no, it says, yeah, success now.
Yeah,
it's not
lost,
tracking.
okay.
So,
I guess if it can adapt, obviously it adapts as the view
Some
changes.
can, right?
Yeah. So, okay, makes
Track
sense.
a fixed thing or a.
But that's really brilliant, you know, to have the,
Because
Let me try
sometimes we'll
mine.
just track if it's small changes from frame to frame.
right,
It could morph all over the place.
right, that's true.
I've
Scale,
got a great
angle.
stationary object tracker.
So I'm looking to buy an ass for myself. So I have some machines and
see, can we get more
I
of
think
it?
it's very good for computers. I have.
So it could even like track shapeshifter, if it's a gradual shapeshifter. If you turn from lizard to bear to
To run.
alley cat, yeah, to me,
Yeah.
whatever, yeah.
Yeah, it looks like this one has an issue with the X. I think it's a different side image.
Have you ever played with any kind of object detection, like YOLO or Google Object Detection?
Say that again?
Have you ever tried any kind of neural network type object detection like YOLO?
Oh,
or-
no, not yet.
Or Google Object API? So I played with YOLO a little
It's
bit.
finding it.
Yeah, I actually modified the program. I'm gonna take that out and see if it works without it.
Or crash.
So you modified
Or-
it not to work?
No, I modified it to add the X value, and it's coughing on the X. It says it's not defined, so I thought each one was the same and didn't run it on all of them, but, let's see here. So if I take it out, it should probably run all right.
I'll put my hat.
While he's doing that, Carl, I've got a question for you. On that finish line there,
Yeah.
how do you know to go left or right? Because it's got a loop there to take you all the way back around the track.
Yeah, so you're talking about this part right here?
Yeah.
Right? And Ray and I take different approaches. So I think Ray's approach is that he's looking at, no matter how the robot is aimed,
Yeah.
he takes a horizontal row, right? And he looks at the number of different areas, black, white. And,
But how do you know to
Oh.
go left or right?
It's a rule that says it'll be a right branch. The rule is in the contest course that says if there's a fork in the road, take the
I
right
see.
fork.
Makes sense.
Yeah, that's
Yeah.
the,
that thing is defined,
Yeah.
that part of
Because
it.
without that, if it was random, go wherever you want as long as it's
Right.
random.
Yeah, no, so it's-
You could get caught in that.
No, you
Yeah.
go back. You just
That thing is,
you go
it's there,
backwards.
in
Yeah.
the rules, it's actually output A, B, and C.
Mhm.
Oh,
So
okay.
for this version of the course, you're supposed to take C.
I see.
But as soon as somebody conquers this, then they're gonna change it, so you have to take A or B or something.
okay.
Yeah, that's where the neural network would I think would struggle with that.
Why?
It wouldn't. It
No,
might-
it wouldn't.
yeah, if it was trained to see that image and always turn right.
Yeah. I mean, it knows that when you see this image, do this throttle and this steering. When you see that image, do this throttle, and as long as in your training, you always go that way.
Yeah, that's
Can't
right.
you expand your image to include 4 blocks?
Sure.
Well, these things
I
got
mean,
wide
that seems a
angle.
logical answer to me.
Yeah, these have got real wide angle and catch all that.
No, you just need a telescope.
So you get extra credit if you can identify a closed loop. I'd say so if I was
That
judging.
would, I think it'd be huge extra credit.
Yeah, a local
Because
closed
like
loop.
Donkey Car only works in the current image, and as those of us that have tried this course have found, if you try and base all of your movement commands on the current image, it's really difficult.
But there is a way to do it. A current image of the whole
The whole
thing.
thing, yeah.
Okay,
Yeah,
all right.
the whole
All right. Never mind.
That's Ron's approach. You ready?
Let's see.
Not tracking.
Not tracking today. That's weird. Usually does pretty good.
As long as it worked at home.
It worked, yeah, it worked at home. There's another tracker that's slower than that I could try.
Oh, this connector.
Let's see if this guy has any more success. He's slower, but I think he's more reliable.
It's more contrast too.
I think you need is to be able to recognize using both, so that you always pick him up.
Yeah, and it's only running it, yeah, there's the frames per second is only 3.21, but that's kind of the characteristic of it. It says, you know, it's higher accuracy, but slower frames per second. KCF, you know, faster speed, but, you know, slightly less tracking accuracy. And Mossy was the one that worked the fastest, but it's already changed perspective and it's still.
There's
still
fairly
tracking.
significant changes frame to frame, so that's pretty good.
Yeah,
I can imagine if you had a really high frame rate, it would be nice because there'd be such subtle changes frame to frame.
yeah.
Well, changing blue to white background probably loses the guy.
Part of the secret of that is that's a physical object moving, and it can only move a certain way. Unfortunately, what we have here is not a physical object you're trying to copy.
Yeah.
And so there's no physical limit on what it can do.
Well, I could.
And I doubt if that tracker will track it. Because it probably, depending on knowing, it's determining the characteristics of the physical body.
Yeah.
Motion.
I don't know. When I hooked up this guy and just waved the ribbon in front of him, you know, I could put a track box on that and it would do it. I can try it again and see if it'll do it. But
But the ribbon was moving, not the car. Did that matter?
well, it's just, you know, kind of like you know, on the donkey car track, you'd have, you know, lines on either side.
Yeah, it might be sort
I
of
thought if
same-
it could track
same idea.
a line and I moved it back and forth, then it should work okay.
So the line would move in the image if you're moving the vehicle.
Exactly.
Yeah.
Same difference, sort of.
Yeah.
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 Funny way of thinking.
The
Yeah.
vehicle is limited to what it can do.
Yeah.
Probably, it's not gonna work when you get to the stair step though. If more than one of those black images is in the image, it's gonna not be able to distinguish the one from the other if they're not connected.
Well, that's why you have the situation where you handle the gap by just continuing to do whatever you did.
Yeah, if you don't understand something go straight.
Just pretend you know what you're doing.
Yeah, if you have no.
That's right.
Keep going.
Yeah.
Yeah, but if it keeps going, you're gonna have, it's gonna give up and crash, so you're gonna have to tell the program, if it loses track, wait and see if I see it again.
Right. Yeah, but, so, if you're not seeing something, just keep going until you do see something and then use that as the basis.
And just assume it's not something that looks very similar, but it's not the same.
Here's famous last words, it works at home. So if I move this around, it should be similar to what the donkey car is seeing as the edge moves. So if I move it back and forth,
You can see it.
and it's not gonna happen very fast.
Depends how fast your car's going.
Oh, that's true. Okay, it's gonna work for my car, because it's not going very fast.
For my car, it's not gonna be moving very fast.
So Ray, if
See what the limits
rotate
are.
the line then, like, if you slowly rotate it to 45 or 90, is it still nasty track?
It seems to. Oops.
Uh-oh, what's happening?
Why
That's
is
weird.
it wanting to follow?
Yeah, that's weird.
Part of your black line.
Well, that was the region that I selected, so.
So if you shake it around and it loses it, will it reacquire it? That's my question.
Sometimes it will.
Oh, or it becomes fixated on the background. man.
I can move it
That's
around.
pretty good.
Yeah.
Can you take it out of frame
Yeah,
for
but
a second?
with the line,
Yeah, that doesn't
if you
work
were,
well when that happens.
if the camera was moving though on the line, it would seem like it would try to, like, no, I'm trying to track that piece of the line.
Oh,
not
actually, yeah.
the line itself.
Yeah, did it pick it back down?
Okay, now do a non-physical flat earth thing and have it instantaneously teleport back in on the other side.
So see it's fixated on the background.
It will pick it up again.
Yeah, okay.
Yeah.
Wow.
Oh, that's cool.
You can't physically.
Slide it,
Yeah.
Yeah.
Okay,
slide
we're
it forward
convinced.
and back. Just follow that piece of the line out.
One way you can get around being able to track it across
This way?
to either side is to
That's what you
move the frame
Yeah,
so it treats it as
but
a
now
truss
it's
instead
following
of
the
just a
end of
shank.
it now, but if you push
Because
it,
geometrically
push the
speaking,
end
the
past
right side of the
there,
frame would be
Oh, well,
closer
it's
to
still
the
follow it.
spring.
So it would.
I think it does. It's hard
It
to
might
say
work
what
if you
it's
had
like.
holonomic
Yeah, so it seems like it's trying to follow the
movement
ribbon, not
across
necessarily.
three
the line
axes.
itself.
and not
Well,
just
but we're,
two.
we're gonna have a continuous
Stuck on the
line,
plane.
and if
I don't
I,
know that that's gonna.
there I
be
can
benefit.
feed quite a bit
It
of
would totally
ribbon
work if we were
in
talking about
and pull it
drum
back out,
or a
Yeah.
sub.
and it still tracks,
You're
so.
still trying to track it if it goes
Yeah,
off.
anyway, it was just kind of a neat thing. I'm not certain it will ever be used, but you could use it in,
Can you let the line down and just move the robot to see if it still tracks that way?
I could, it's kind of 6 to 1 though, isn't it? I mean.
Yeah, same difference.
Not
Yeah.
if it's a curved line.
Oh, well, but curve line, it's going to appear that, that for that little segment of line that it's actually, well, okay, yeah, I guess it's going to curve a little. I don't know if I can curve this ribbon.
We don't have our tiles here, do we?
But it seems to track it pretty quickly, so even if you started to go off into the weeds, it could probably pick it back up.
Not like your finger.
Yeah. Anyway.
So if it starts to track your finger, does it decide it likes your finger then? And then the question I have is then if you show it the line, does it know, oh, that was what I originally learned, or does it just adapt itself to whatever?
Probably it adapts itself as it goes.
Yeah. I'm not
Catch
certain.
those
I thought it
shapeshifters.
tried to
The
look
raccoon
for
becomes a.
a similar
Yeah.
image, frame to frame, so not much change in the image. And if you give it like too much, say like if it obscures it or if it goes out of frame, it loses it. And then if you don't come back into that same region, it won't reacquire it, so. Anyway. Okay. On to the next one.
Yeah. Probably not even using those full frame of data, it's just using a little slightly larger frame around the current frame to say, okay, here it is now. Move it, move it, move it, move it.
I wonder if it takes, like, if it takes the track box and slews it across the image. I wonder if that's how it does the match. If it takes that sub-image from the current frame, and then on the new frame, it takes the sub-image, sweeps it across,
Oh, but
and
it,
it
but,
finds
but it didn't like to see it again on the right side if you had it on the left side. The
Yeah,
one
so
that
it
sees the left
sensitive
side
to the
again.
prior position.
Yeah.
It looks like what you were saying, that it just includes a border around it and says, is it, looks similar to where it was.
You've all seen
Well,
the,
you'd be able,
the
you'd be
one
able
where,
to run a lot faster that way, but you're not looking at the whole frame, you're just looking at a subframe area.
have you seen the one where, and it's a video, obviously, Microsoft does it, where it's tracking, you're just walking down the street and it's identifying everything as you're walking by, right? So what if it learned what each and every one of those little squares was as a, you know, just instead of a horse and a sign and a car, it's that block, that block, that block, that block, that block. Could it learn enough and be trained enough to be put together and know, oh, I know what it's doing, you know, and go on its little merry way, you think?
I think for that, you'd have to figure out how to segment the image. Right, you'd have to figure out how to segment.
Yeah, I know. Well, you've got 6 by 12 segments.
No, he's talking about how to parse off different things in the image. Is that what you mean by segment?
Yeah, like you'd have to define what's the thing that you're trying to train it on. So,
When we use a donkey car, you kind of manually control it around the track, and it's in training mode. That's what it's doing.
Oh, it's just,
It's looking at each individual image and saying, do I go left or right or forwards?
Oh,
Or some
okay, so
degree
it's a
thereof.
direct approach.
So that's how it does it. You have to run it first. And I guess in this challenge though, it's like the software has never seen the track before, it's just gotta work.
Okay. Well, you could run it in simulator and use the results from the simulator.
Yeah. Anyway, this next section, it was to try to get, you know, not use a separate LiDAR, but do it again through OpenCV and optically versus, you know, having something mechanically scanned and all that kind of stuff. But as the phrase says, there are more ways than one to skin a cat. And I was kind of curious where that phrase came from. And apparently it was, I guess, first documented in like the 1850s or 60s. And the only reason why I could think you would want to do that is that cat maybe was on the menu.
You say it was an Oreo in that?
No, this was United States. They said it was you know, from the U.S. So I don't know. You know, why else are you going to want to skin a cat where it's fur and eat it? You know? Anyway, so to measure the amount of time that I've been working on this, and Carl has been working on this. It's, you know, we had to use geological time. So, you know,
Thanks, Ray. That's cool.
I'm over here, and you know, the Mesozoic, and Carl's way over here, and I guess it's Paleozoic. Anyway, so Carl had been working on the simulator for a long, long time. And, I think I would have given up long ago if I hadn't, you know, made the results that he made. But this whole idea actually came from the Seattle Robotics group. I think it was over 20 years ago. A guy did it with basically an NTSC or analog camera and a CPLD and lasers and filters similar to what I have. But so this is kind of the, you know, more modern approach on that. So you can get, there are a wide variety of LiDAR modules out there, and they kind of range in cost, speed, you know, the amount of time, you know, that it actually takes to acquire a certain number of readings. So like the RP LiDAR, it's about $100, works at about 5.5 hertz. It does 360 degrees. It's similar to the Nito LiDAR that James sells. That's his, I guess the name of his product, right? Get Surreal, or his website.
That's his website.
Website, yeah. So the Nito LiDARs will actually do about 6 meters, 5 hertz. He was making a little money on that because he's charging like 155 now. I
think that gives you the controller and the stand and everything. It's more than just the LiDAR.
More than just the LiDAR, right? Yeah. Benawaki at least that's how I pronounce it. That's kind of it's does about the same range. It's a little bit slower. If you stick it or combine it with a servo, the total cost is maybe $50. You can do 180 degrees. The time of flight sensors from, I guess those are ST. Yeah, ST. Considerably less cost. You can also stick it on a servo, do 180 degrees, but it's slow. I think each reading you got to allow like I want to say 33 milliseconds. I think is what they recommend.
But you could add additional units. You don't have to have just one.
That's true. Yeah. Yeah.
And you could have 4.
Right. And I was sticking, always thinking that this is going on a servo, so I could get at least 180 degrees. The approach with the filters and the laser, and the Raspberry Pi and the Raspberry Pi camera, that's about $80. But the kind of thing was that if you purchased the Raspberry Pi and the Raspberry Pi camera, you could use it for a lot of other things. I think the OpenMV can be used for that. I actually tried to use the Pixie Cam to see the laser, and it's kind of limited in what you can do with it as far as processing. What you really want is to find out like the different heights of the line in the image, and that tells you what the distance is. And you can do, you can set that as a signature with the Pixie Cam, but it just kind of highlights the whole thing, and it's just a little bit more difficult to use.
Is that the 2 or the 1?
That was the 1. Okay, yeah.
Because the 2's got line, detects lines now. So I'm just saying it might be
work.
Something you might be able to make it work for the laser.
For that, yeah.
Something you have to keep in mind though, the difference between the LiDARs and the time of flight sensors is the LiDAR or any laser rangefinder is pinpoint accuracy. There is no field. The time of flights, I think they say there's about a 5-degree field.
Right.
So depending on what you're trying to do, if you're trying to like not run into something, the LiDARs are really not that great because you only have that level as even the RP LiDAR as it's spinning. Right. Yeah. You may have 360 degrees, but it's on that plane.
It's in a plane.
Exactly.
Yeah. Right.
Whereas most of the other rangefinder and time of flight ones, there's a cone, so you have this detection region, basically.
Yeah, and it gets bigger the further out it goes. Yeah. Anyway, so then James came along and he found this thing, which do this, right?
Go into presentation mode.
Oh, okay.
You can control click it as well.
Do control click on it.
Oh, control click? Oh, okay, that'll work.
I think you still gotta be right
In presentation mode to make that work.
Oh,
Yeah.
you do? Okay.
down in the lower right, you can just click on
Lower right.
yeah, over by the slider bar.
The other right.
The other
Oh,
way.
sorry, my other
Yeah,
right.
right there. Go up just that.
A little bit
last
more,
little,
one
no,
more.
the one on there, there you go.
There we go.
Okay. Looks like it's gonna do it.
You done a new skill today?
Yep. Uh-oh.
No.
Oh, that's not good.
Are you connected to Wi-Fi?
I thought I was.
Can you pull up?
Ooh, no, guess I'm not.
Looks like Carl's gonna have you beat
Probably.
So you might want to just abandon hope over there.
Then OP.
Right.
Oh, yeah, yeah.
YouTube video comes preloaded with stuff like that.
Okay.
You can use your.
What do you want to see
your
here?
arrows to
Right?
do pages.
Can we pull a video up of this thing, or what?
Anyway, so this is kind of similar in design. Do they, is
Click
there?
play.
What? Oh, yeah, you could see this. This is doing essentially what I'm doing. It's got a dedicated camera in the top with, I think, at least 180 degree, field of view lens. I think he's got a rod lens in the base there with an LED. And so like in my setup, my laser is pointed out, so it's horizontal. It actually has a line lens on it, so it's drawing a horizontal line. And then if my camera is tilted down, whatever it sees in the field of view, it's thinking? Okay.
Makerspace Wi-Fi has it out for me. It doesn't matter what computer I'm using.
Saturdays are busy days.
But they have these,
A lot of people do.
wow, it's just really
They still
still.
think again.
All right, not worthy.
Okay. Well, that's it for Carl.
There you go, it started to go.
You got something going?
Yep, there's something, okay, hang on, let me get over there.
No audio?
No audio.
Anyway, yeah, I don't think these do. Yeah, so this is kind of the idea of the, 1 point, so if you just get one distance, but now if you rotate it, you get 2D, which, individual points around the thing. And then I think theirs, the third video, they describe how it works and kind of show you. So it's basically doing the same thing. I'm sure they've got a dedicated part to it, a dedicated processor, and it's running much faster than OpenCV is, because it's a continuous line, nothing rotates, and they basically just process it,
So it
whatever.
goes on the line and the camera looks to the line and does some processing and tells you stuff.
Right,
Yeah.
it gives
Yeah, there you
you
go.
180 degrees, and that one will work at like 100 hertz, which is much faster than.
It's like a zillion time of flight sensors.
It's actually doing, I'm pretty certain it's doing like, image shape correction.
Well, look up 3D imaging scanning. They explain to you how it's done. It's using the same principle.
Yeah. Yeah, so if you look at the exploded view.
They like that, yeah.
Well, that one's moving it around so you can get like a true 3D scan. That's mechanically moving the sensor, I think.
So is the line laser image sweeping, so it's a camera and a line laser, and is the line laser being swept?
In that
Other
one
than-
image
other
where
than
there are
creating
multiple
a
dots,
line.
There are, it
Okay,
was
okay.
being swept.
So it's a one-dimensional, a line laser with a oscillating, vibrating, whatever, sweeping the line across the,
No,
Uh,
this one,
no, I thought that
there are no
was-
moving parts. I think it's a lens that splits the line laser onto a two-dimensional plane.
Right, and they're actually
Okay.
moving the whole unit to get like a 3D scan.
oh, I see, okay,
Yeah.
okay,
So this-
gotcha.
Yeah, this just does a plane 180 degrees.
Right, okay.
Out front, so, and that's with the, it looks like it's got a big fisheye lens on it, all that kind of stuff. And it's got a dedicated processor, so.
And what is the status on the Kickstarter? Do they expect delivery?
I think it was successful.
Yeah, I think it was, you could get it for $99. I don't know, usually, it goes up a little after Kickstarter phase.
August 2019, estimated early bird delivery.
Yeah.
Keep scrolling, see which one it's on now.
Oh, it's past the
close.
Kickstarter.
Yeah.
Yeah.
Are they taking orders? Because if they're actually taking orders, you're guaranteed you're gonna get it.
Something
Because
like
they have to
that.
fulfill those before they go back and fulfill their Kickstarter orders. just a word, I've been burned several times. Just so
Oh,
you know.
yeah.
Wait until they go into that pre-order stage.
Anyway, they're all, this is all how cheap can you get kind of stuff. So these are things I tried as filters. And this is in front of the Raspberry Pi, no IR camera. It doesn't have an IR filter in it. So the, exposed 35mm film, floppy disks, polarizers from 3D movies, movie glasses. One of the better ones was actually the plastic lens. It was in front of an IR receiver in an old VCR. It's a little square plastic. The LCD shutter, Adafruit sells them. They stick them in keychains to, and they're run by a little teeny row of solar cells, so it kind of flashes on and off, either lets you see or blocks, some image that's in behind the LCD. IR pass film, there's a little piece of it that you get with the no IR camera. And then finally broke down and purchased some decent lenses with known specifications. That's what I have on that filter, or in that filter switch now. The regular camera actually has one of these in it, and it's, it basically cuts down ultraviolet and infrared and just allows the visible wavelengths through. And they're somewhere between 420 and, I don't know, 690 or so. And so the no IR camera doesn't have this. The regular camera does. Oops. That was the company or the website that I got the lasers from. So I actually got several others in the infrared. I think I have an 820 and one other one, I forget what it is, but the 780 worked the best because that's the closest to visible.
So when using a regular laser, how do you go about using that?
What do you mean? This laser?
Yes.
It just has a line lens on it, which, and you align it so the line is horizontal. And it has, I have a filter, it's actually it's called a long pass filter on it. But just wanted to give you an idea of what the laser was $12. The line lens was like $3, and you can get them in, different widths. It looks like a Fresnel lens on the front, and it's not actually a true line lens. It actually makes it into like a series of dots. So if you defocus the laser a little bit, it looks like a line. The lens that they have on that thing, I think it's actually referred to as a cylindrical lens. So if you have I had an acrylic rod that was about maybe a centimeter across, 10 millimeters, and that actually worked pretty good. I'm sure they went and got a molded lens. It was probably polished. It's much higher grade than my little piece of acrylic rod was, but it worked fairly well. Oops, keep hitting the wrong button. This is what the filter switch is, or what it looks like, and these are the filters. Actually look like, for what our eyes can see, like mirrored surfaces. Looks like a little piece of mirror. You can get them with the barrels on them. This one you can actually screw. It's made for the 12 millimeter lens. You can get them with other, like I think 8 millimeters common. I've seen them with 14s, or you can get them without the barrel.
And does that switch between two filters, or filter or no filter?
Well, it's actually two filters. These are the two filters here. This one is it's the the visible pass, or the UV and IR cut that comes with the regular camera. That's what it would look like. And in this photo, it doesn't look pinkish, it looks more bluish, but if you're just looking at it, it has like a pinkish cast to it.
So you basically energize that and it flips
Yeah,
the other
it's just a
filter in
mechanical, kind of like, I don't know.
front, like a solenoid.
Kind of like a solenoid, yeah. So it's, there's a little pivot pin right here. And it just pushes this thing in one direction when you energize it, 12 volts in one polarity and then switches it back in the other. And that's, like I said, those are in just about every security camera that has night vision in it. And in, for daytime, it's got what the regular camera has in it to filter out UV and infrared. And then the other one, I think it looks like it's got an anti-reflective coating on it to allow visible and infrared to pass through, and that's when your little lights come on. Filter switches were cheap, and the long pass filters, they weren't that much. And I bought a bunch, of different wavelengths. Like these are actually, that's kind of reddish orange, and that's more red, I think. And I thought the narrow band pass one would actually work better, but the long pass worked better. So narrow band pass just lets a few wavelengths of light in. Like this one is between, it's supposed to be centered on 650, but the, at the 50% mark, you're only down to 639 nanometers or up to 666 nanometers. So it's not very wide, and I don't know that when you buy a cheap 650 laser, if it's exactly at 650, I'm guessing not. So, it's probably close to that, but,
Might be in the sideband.
Yeah. So, and like I said, you're not many wavelengths off before, you're attenuating most of the light in the laser. So I actually used what's called a long pass, so it's kind of difficult to see, but the visible light would be in this range, and then this is the longer wavelengths of IR. So it lets pretty much everything from, 680 on up through, and blocks anything below it.
Sorry if I got kind of stupid on this. Well, why you're gonna? I can get why you'd want one or the other. You want to be able to flip-flop back and forth just so you can have visual images or look at your IR laser stuff.
Right.
Okay.
Yeah, like so far with that lens, all the images that I've shown are with the visible pass, or you could also call.
So you wouldn't
UV
want to do
monitor.
multiple cameras. You want that point of view.
There's only one cable for the Raspberry Pi for
Alright,
camera, so.
okay.
Yeah, I can either.
I see. Okay.
You say it's easier to switch filters than cameras.
Yeah.
A question I've got. So when you're dealing with real optics and you're dealing with real film, all of this comes to play. But as soon as you move into a digital camera, imager sensor,
Yeah.
you're now dealing with a bare image, what they call Bayer, B-A-Y-E-R.
Yeah.
And so every single pixel already has a filter on it. You have your red, green, red, green, red, green, red, green, then you got blue, green, blue, green, blue, green, blue, green, the row below, and you just keep alternating.
Right.
So every pixel already has a filter on it, and you're getting only the one color's perspective when you're getting the raw data out of it. Now, of course, your software goes and plays with it and does interpolation for you.
Right.
I had to do this stuff at a raw level
Uh-huh.
with some work I did in the past.
Yep.
And so now your job is to put the image back together and guess what that pixel's supposed to be based upon the colors of pixels around it.
Yeah. But the sensors though will respond to infrared light. At least at 780 nanometers. But it's not like a sharp cutoff. It just kind of rolls off in the infrared band, and it does respond to it. So anyway,
So you're saying essentially the color filters don't filter very much from an infrared standpoint.
yeah, they'll
It just
still
goes all
let
through the filter.
infrared,
Okay.
and that's why they have these other filters in front of the camera.
Okay.
Whatever lens. Well, it's a lot of cases it's behind the lens, but in the optical path, you know, before
Sure.
it hits the sensor.
Where's the sensor?
Yep. Anyway,
Those
so,
those filters in front of them have response in the color you want and also in the infrared.
say it again? Yeah.
The filters that's in front of each pixel, I think, has the response in that frequency, but they also have a response in the infrared.
Yeah, because you get a fair amount of
There's
infrared
a-
through.
Their TSO, touches optical, whatever it is, sells a little sensor that's got little LEDs that are for picking up the color of light. But there's one in there that's unfiltered, and then there's 3 that are filtered for the different colors.
Right,
But-
yeah.
But what comes out of the 3 that are filtered has to be modified because it's also receiving the same thing as clear.
Yeah.
So if you get that data sheet, I think it'll show that.
Yeah. So, yeah, they do respond pretty good. And I also found that the Pixie cams, the Raspberry Pi cameras work a little bit better at, you know, they seem a little bit more sensitive to infrared versus a Pixie camera. So I'm gonna see if I can get this to flip.
And again, you're using the NOR camera, right?
Yeah.
Okay, so especially the bare filter on that probably is, well, I guess it's probably the same bare filter, it just doesn't have the IR filter in front.
And it's not gonna flip.
For a second, I thought you were filtering out bears, and then my brain caught up. What else are we doing here?
Bear.
Bear,
Yeah,
okay,
like
bear
the aspirin.
filter, okay.
Yep, I got too much glue in it. It's stuck.
So that sensor, Will, you were saying, was it TAOS, how, TOAS?
TUS, Texas Optical Society, I believe.
Oh, there we go.
By the way, they've been bought out by somebody else.
Okay.
Yeah, this was, I actually had to take out the filter that was in this thing, and I had to glue in another one, and I got too much glue to it, so it sticks. Which is a pain in the butt.
It's now known as OSA, the Optical Society of America.
Who?
OSA, Optical Society of America.
Wait a minute, he's confusing. No, this is a manufacturer, is that, so you're aware that that line sensor was,
It's not a line sensor, it's
oh, ambient? No, wait a minute.
it's for detecting color.
Oh, okay, okay.
Sorry, I thought you were just talking about the study they'll publish a lot of the papers for these.
Oh, okay, no, he's talking about a manufacturer of a ambient light sensor.
Used to be here in Texas.
TAOS? Oh, well, okay.
Oops. Switch
T.
this guy.
It's pretty good. Ray can do a lot of real-time stuff. Real-time repairs, real-time coding.
Very tedious to repair.
Well, you can't make coffee.
Okay, there we go. Let's see.
Are we restricted on time in this room or anything?
Oh, I don't know what time.
It's 2:07. I'm just making sure we get our show and tells in and stuff.
Just walk to the floor, but I think it's,
Is that hardware?
Okay.
as you were going everywhere.
Okay, so that's the actual image that it's seeing. It looks like the, oh, and it's probably not.
Are those draggable? Or, that's okay.
Oh, yeah, the images, yeah.
Yeah, if you can move them together, then I can zoom in on them better.
Oh, okay.
Just for our home audience here.
Yeah, these are pretty small images.
So what are these two images that we're seeing?
One is the,
Looks like Ray's cat at home.
yeah, no,
No.
it's a thresholded image. It's
Okay.
it's on the table there.
Reminds me of looking at security camera and it just, oh, yep, there's the raccoon.
Yeah.
Nope, okay.
Bobcat.
Okay.
Wolf.
Yeah, there's the bobcat. Oh, there went Sparky. The two images merged. You knew that your dog or cat has been consumed by it.
That guy.
So Ray, is the idea that you're projecting a laser line and then you're using CV to look at it?
Yeah. Doesn't work so well with Donald Trump's keyboard.
With one of those lasers that he talked about. So you use one of those lasers and he has that thing that, you know, like you use to level things.
Yeah, it looks like the
So you didn't have to.
laser rotated.
You just fire power shells. So power shells, similar to
Cool.
command, but it has that.
Wait a minute.
Okay, so the laser is shining on this can right here,
Cool.
and it's you can't see it. It's, well, I don't know, maybe some people can see it, but I think if you're, you know, extraterrestrial, you might be able to see it, but I think most humans can. Anyway, so the image on the left, kind of the pinkish one, is where the laser hits the can, and let's see here from this perspective.
Doug was here. I wonder if this camera has infrared
Oh, it might.
sensing ability. Wait a
Yeah.
minute. Well, okay, I won't try to figure it out. There's too many buttons.
Okay, so the closer the image is, the further down, or sorry, the closer the object is to the camera, the further down in the image it appears. So if it's going to, I don't know. So there, it's getting closer and closer, and it's appearing further down in the image. So you can use that to determine where it is in the field of view. The further down it is,
How far away it is.
yeah, the closer it is. And I'm actually looking, you know, I don't really need to know, you can calibrate it for distance. If I'm just looking for the closest object, you know, I'm just, again, looking for an X value. Where is it in the field of view so I can steer towards it. So in this case, this is a lot of pixel diddling as well. It's, you know, it's looking at the whole image. Converts it to gray, blurs it, and thresholds it. So that's the thresholded image here. And let's let's see, is that thresh? Yeah, that should be thresh. Oh, wait a minute, sorry. That's actually the raw image. Yeah, that's not threshold, even though it says thresh, I should have changed it. Yeah, here, it's actually the image, not thresh. So if I change that to raw image, that's what it would be. This one actually does a Sobel transform in the Y direction. So that line of pixels here should actually correspond to the where it goes from black to white. So kind of that top edge, because it actually starts at the line 0 and works its way down the image. And the other thing that this does, it creates a histogram of the number of points. So these little teeny dots here are a histogram of the number of points in that row. And it's basically a plot out of it. The little 2 dots on the top are the first pixel in the row and we're considered the last pixel in that row. And it's looking for 5 or more pixels in a row. So this average CL, right now it's like 73. That's approximately in the middle of the image. If I bring it over, let's see, oops, it's in my arm. Yeah, that goes towards 160, and then that side should be closer to 0. Oh, I'm out of the field of view. Yeah. So that's the 0 side over there. So, so that's pretty much what it's doing. You can, if you have multiple objects in the field of view, you can see that these are very small images because it takes a fair amount of time to process through. You can see the update rate's not that fast. But that's, again, the histogram of the number of pixels in that row, and that's the number of pixels in the rows of that line there. And it should track the lower one, because that's all it's doing right now. So if I move the one that's closer in, so it's actually tracking that one. And you can have it set up to track the other one. So you can do it. It does work. It's certainly not as fast as this thing is, but you could have a setup to find cans. You can use it to find the goal, and it's not sensing the color. There's it's infrared. There's not really a color associated with it, even though the raw image looks a little purplish, and it works in very a wide range of lighting conditions. Like you could turn the lights off and it would still work, whereas if you were doing color blob detection, it disappeared. Or if your lighting changed that much, it would still work.
Now you've got an IR, a visible light cut filter on that now?
Yeah.
Can you kill the lights?
Yeah, go ahead and cut the lights.
We know you want to do it.
Yeah.
See, that works just as well.
Still working.
We got the engine.
You worked at home?
It worked at home, and it works here. It's amazing.
Well, we
so
think it was still working.
That's kind of a neat feature about it. You can use the visible lasers, but if you get one that's 50 milliwatts, it's pretty bright. So I don't know. It's just we can't see it, so we don't think it's there, kind of thing.
Therefore, it can't hurt us.
That's
Yeah,
right.
that's
It
it.
can't hurt you.
Yeah.
I wouldn't go surfing to the end of that laser. But anyway.
So Ray,
Yes.
with your tinkering with the blob detection and with this line laser technique, which approach do you think you'll be most interested in using for cans, or will you combine the two?
I think I wanted to use the visible, blob detection define the cans, because that seems to work fairly well. I even had one setup where it was raising and lowering, the laser just above the can, so it would just shine on the wall, because it's just easier to process.
Can filter,
Yeah, so, because once you get the can, you're looking for the goal, and you don't need to know where the other cans are. I was gonna try to use both, but kind of like I said, there were two other shiny things that, distracted me. One was line following, and now there's this, so, it goes back to that geological, that's why it's geological time, it's not, you don't work on it continuously, so. Anyway, okay, oops, wrong mouse.
Whatever's bright and shiny today.
That's right, that's, oh, look. Oh, no. Okay, there we go. Let's see if that was the end of that.
It's
Yeah,
not
okay.
this problem here, but the LiDAR won't tell you which object is closest. It's dealing with objects of different heights. So
No,
that
it doesn't matter about the height.
Well, as long as everything's,
Doesn't matter what the height of the object is.
Well,
Right.
it does, because if the LiDAR line isn't hitting,
Oh, yeah.
you've got a short object and a tall object, the tall object's always going to appear closer because it doesn't even see the short object.
Well, yeah. I mean, it has to be in the field of view.
That's why I was saying it doesn't fit this problem, but it's a future problem.
Right.
If you're talking about object detection.
So what would stop you from taking something like this high-vol LiDAR, put it on a servo and make it pan up and down?
Oh, yeah, you could get 3D images from it.
You get 3D images.
Yeah, yeah.
Couple of scans,
You
maybe it
could
tells
do
you
that
where
with-
things are and go. I don't know, but.
Yeah, yeah.
You really don't need to know what's behind you, though.
Not really, no. Yeah, so 180 is, probably good enough.
It's behind, who cares?
Yeah,
You already ran over it.
that's right.
That's right.
Okay.
Already ran over that cat with skin.
The last thing that I was gonna try to show you. Was this.
oh, the Kinect.
And kind of the goal with this was to make it into a very reasonably priced stereo camera, because you can get distance maps out of it. And supposedly, you could look at them with OpenCV on a Raspberry Pi, but I haven't been able to do it yet. But I can show some things with it.
Yeah, you're pushing, I know a little bit about some of those things, and you're pushing a whole lot of bits into a Raspberry Pi, man.
Yeah,
I mean, a
it is.
whole lot of bits.
Yep, it's like drinking out of the fire hose.
Yeah.
And I can show you, it loses packets, and I even tried it with the B+, the 3B+.
Yeah.
And it still doesn't work.
Does it
Every
have-
time I played with all those things, I've had to have a decently powered laptop to get any kind of decent results out of it.
It's just too fast.
It's just too fast, it's throwing a whole lot of info at you.
Yeah.
Is there any way to tell the camera to go into a lower res mode?
Not that I'm aware of. Okay. Because those things are pretty much, maybe in the V2, the Windows desktop V2, maybe, but those things are pretty much, you plug them in, you tell them what you want, and they just fire it at you. Now, if you don't want like the video, okay, if you don't want like the IR, okay, it won't fire it at you. But once you tell it to fire it at you, it's going to give you, it's coming.
There's no knobs and switches,
No.
it's on or off.
It's on and on. Okay.
So we're talking 2 video images, 1 infrared and 1 visible,
Yeah.
2
And
cameras?
It
Okay.
overlaps. In fact, if you have one of that no IR camera over there and you look at that while you're blasting it out, you'll see a grid of dots
Yeah.
on everything you see.
Right, okay.
Yeah.
You could drop
So it has like.
every
that projects it.
4 out of every
I
side.
don't know if it's a
right?
laser, but it's throwing an
Yeah,
IR.
it's
And
downsampling
it's on
the
a district
infrastructure.
measurement. They
It's
convert, and
downsampling
it
on the infrastructure.
does internal to that.
Well, you're just seeing the drop images,
The
and
thing
you're seeing
looks
down
as the video, as the
So
IR
it
blasting
down
comes out,
temporal,
overlays
down
them, and it gives you a whole bunch of difference. There's
I
there's
think
some
he's
smarts
doing that
inside of it.
temporarily by default because it just can't keep up.
And it, you know, it does joint detection and everything, so it can look at a person and know your wrist and all those, and it does that on the camera.
Yeah.
It's meant for a living.
Dedicated.
So
Yeah, it's dedicated hardware.
No, on the V2, they designed it for have the same, like, just very between the two as like the center section is, because there's possibility you can use it.
Okay.
This
So-
one, I think, is a bit.
Well, let's look
Oh,
at the
it is
cans.
working, okay.
I should probably look at some of the people. So that's the, this is the distance map here, so things that are closer are gonna appear, you know, I think up to white, so if, yeah, the closer you get, it's gonna go from green to yellow to
Yellow,
red
orange.
to white.
You're getting warm.
Yeah.
Warmer, warmer. That's it, I've been interchanged.
But, so one of the things, the little meter up there is up to 95%, and the little thermometer is on telling me that the Raspberry Pi is getting hot.
Getting hot.
So, you know, you can blow on it and get rid of the thermometer, but it doesn't,
So this is not OpenCV, this is just something that connects directly to the.
yeah,
Kinect.
it was code that was written for, you know, specifically for the Xbox, you know, 360 or the Xbox One.
But have you been able to interface to that code? Could you get those colors, or
Nope.
it's more like a demo, basically?
Yeah, at this point with the Raspberry Pi, I think kind of like he said, I'm gonna have to, and
Really?
I'd like to pick your brains on that. Have you
Oh, well,
actually used it?
I don't, it's been a while, I've slept since then, that's just what that's what was left in my neurons to fire to tell you what was going on. But I'll be happy to talk to you though and figure some more stuff out if you like.
Yeah.
But that was running on the Pi, correct?
Yeah, it's displaying the image on the Pi.
Okay. Well,
But when I try to, you know, open an OpenCV program, and this one is just the mapping, it's not both images. And that one doesn't take quite as much, but you're up at 89%. And if you do anything OpenCV, it just kills it. And then, yeah, the other thing that's what I noticed there, like if you run it here.
Well, I wonder if you could start and stop that, start it, get a color, and then stop it, and then go do your stuff, and, you know, might have a very, very slow frame rate, but I don't know how fast you can start and stop the Kinect.
Anyway, this is, they got weird names to this one. This one's called Chunk View. I don't know why. You can see where it's losing packets, you know, 32 packets lost, you know, 43 packets lost in 446 frames. So it definitely seems like it's having a hard time keeping up. And even though a lot of these you're grabbing, you know, one frame in, you know, maybe in 10 or so.
Yeah.
It's still, it couldn't even open up, you know, some of the things. But I'd love to be able to use it on a platform because it's
an HD camera in there, so it's blowing all HD at you. You don't get a chance to say, give me the little bitty thing that I care about.
Yeah, there didn't seem to be any way to resize it, you know, to shrink it down to like 320
It needs
bytes.
one of Jeff's graphics card processors.
Yeah,
It's on like
A graphic
gas
card
power generator.
translator to the Raspberry Pi.
Yeah.
A downscaler.
So it's Raspberry Pi can.
But anyway, so that was the one thing that I obviously did not do. So, but
All right.
that's the end of the presentation.
Yay!
So yeah, because stereo cameras are SparkFun sells two. There's one that has a really kind of a narrow field of view. It's only like 60 degrees. That one's like $180. And you get the one with like, you know, 90-degree field of view. That's like $400. So, and that was, I think that one was $10 at Goodwill. So,
Yeah.
you know, so I thought, you know, I'd try it, but it doesn't look like it's going to work. Anyway.
So should we move on to the donkey car? Or?
Yeah.
Yeah.
And what do we want to do? Do we want to take it's been like 2 hours. Do we want to take a quick break or we want to just
Yeah.
press on?